A load balancer is a networking component that sits between clients and backend servers. It receives incoming requests and intelligently distributes them across multiple servers so that no single server becomes overloaded. In system design, a load balancer is one of the first building block used to achieve scalability, reliability, and high availability. A formal definition would be like a load balancer distributes incoming network or application traffic across a pool of backend servers to maximize availability, improve performance, and eliminate single server bottlenecks. So generally, how this load balancing works is it's a simple request flow. Basically, it starts with the client which sends an HTTP or TCP request. The request reaches the load balancer. The load balancer selects the best backend server. The chosen server processes the request. The response is returned to the client. So the flow would be like from client to load balancer to backend server and return the response back. So the client never needs to know which server handled the request. And you may wonder like why do we need this load balancer? If one server receives all traffic, it takes a lot of time to process and it may sometimes crashes and causes downtime. And performance also drops during the peak traffic. And for scaling, it requires replacing with the bigger servers. But if you use a load balancer, the traffic would be distributed across many servers, and it does the healthy checks of the servers to before sending the request to the particular server. And requests are being shared to maintain the low latency period, and you can add more backend servers horizontally. These are some of the terms you need to understand. One is backend server pool. A server pool is a collection of backend servers capable of handling requests. If you see that example, we have that server A, server B, server C. So these are three servers. The load balancer routes traffic to any of these healthy servers in this pool. Next, we have the healthy check. A healthy check is a periodic test performed by the load balancer to verify whether server is healthy. Usually, we do common checks includes like status check, TCP connection, custom application endpoint, and if the server fails the check, it is temporarily removed from the traffic. So it prevents the request from reaching the failed servers. Next, we have active connections. The number of requests or client sessions currently being processed by the server. So the load balancer can choose the least busy servers based on the active connections. Next, session persistence, also called as sticky sessions. Once a user logs into server A, subsequent requests continue growing to server A, used when the application stores sessions data locally. Example, shopping cart or login sessions. Challenges can reduce perfect traffic distribution.